So we are in section 2.1, and we had just discussed how to solve a rational equation. Now we're going to look at this one. And so we want to know when the values for when y1 equals y2, and here's y1, here's y2, and this right here, because it's saying to find all values of x for which y1 equals y2, what we can do is substitute this in on the left side of this equation here, and substitute this in for the right side. If you set them equal to each other, then you can find the value of x. So it says first we begin by finding the restricted values. And so remember, there are some values that you cannot put in for x here, because it's going to make the denominator, if it makes the denominator 0, then it will not be a solution to the equation. So we have to check for the restricted values. So x plus 4 is equal to 0. And then subtract 4 from both sides, and we get x is equal to -4. So that means x could not be -4. So here's our restrictions. Then I'll take the next one and I'll say x minus 4 is equal to 0. Add 4 to both sides here. I get x equals 4, so x cannot be 4. And then I'll do the same thing with the denominator on the right hand side. Now this one is a quadratic equation, so there's a different way to solve quadratics, but because this one has no middle term, then what we'll do is we can isolate the x squared by adding 16 to both sides to get this. And now I can take the square root of both sides. And I end up with x equals to plus or minus 4, which we already have. So we know there's these restriction here. If we end up with a value of -4 or 4, then we know that we can say that there's no solution here. So let's move on to solving this. So we'll notice that on the bottom of this page that we have x squared minus 16 over here. And now they have written x plus 4, x minus 4. So how did they go from this to this? Well, this is called the factored form. And we have taken the x squared minus 16 and we factored it into two factors. So this is something that we're going to be working on with quadratics. But when just being introduced to it here, I see that this one, why is this called a quadratic? Because it has a squared x. But this one is called a difference of squares. And the reason why that x squared minus 16 is called a difference of squares is because each of the terms, this term and this term, are both squares. Now look at them. X squared is a square, and so is 16. Remember, you can take 2, square it, you get 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So when you have a difference of squares, meaning there's a minus sign in between, they will factor by doing this. Take the square root of the first term and put it in front. Take the square root of the second term and put it here. Put a minus sign on one, put a plus sign on the other. And so that's where they come up with this. So we have factored it into this. Now, we are going to multiply both sides of the equation by the LCD. Well, this one, the LCD for this one, if we were to make our box to do this, let's grab a whiteboard, you will see that it looks a little different than our last ones. These we had 2 times x, 18, 3 times x, 11 times x, 22x. This time, my x doesn't have multiplication in it. It has addition. So I have a factor of x plus 4. That's one denominator. I have x minus 4. And then here I have x plus 4, x minus 4. So these are the 3 denominators. So if I was to look at the factors, this one is different than what I did in the last problem. This whole thing is a factor. This whole thing is a factor. And here you've got an x plus 4 times an x minus 4. So the LCD for this, take the highest in each one, would be made up of x plus 4, x minus 4. So this is my least common denominator. And I'm going to multiply both sides by x plus 4, x minus 4. And so that's going to get multiplied by everything. So let's write it out so I can see what's happening. So I'm going to write this out in 3 places because remember it has to be multiplied by all 3 terms here. All right, so now putting in the original part, we've got 1 over x plus 4, 1 over x minus 4 is equal to, and then this left side, 22 over x plus 4, x minus 4. So now I'm going to see what divides out. Remember, the goal here all the time was to divide out, get rid of, clear the fraction. So get rid of the denominator. That will divide out this. This will divide out this one. And here, both of them divide out. So what am I going to be left with? Well, I'm going to have x minus 4 times 1 plus x plus 4 times 1 is equal to 22. So multiplying by 1, distribute that 1 to end up with this. Much nicer looking problem to solve than what this started with. So now I have to combine like terms. Remember there's a 1 on the front of this x. So these are like terms, the 2 x's, and then I've got the 2 numbers that are like terms. So on the same side of the equal sign, I'm going to say 2x. And here I'll have minus 4 plus 4 is equal to 22. So that zeroes out, and I just have 22 on the right side. And now I'm going to solve for x by dividing both sides by 2 to get x by itself. So x would be equal to 11. So this is my proposed solution. Take it back to the original, and you have to go back to this original. So going back to the original, use the calculator. And wherever you have an x, put in 11. Notice how I'm surrounding my expressions that are part of the fraction with the parentheses. So this is the left-hand side. Hit enter, I get this value. Then I'm going to go to the right-hand side. I'm going to say 22 divided by parenthesis 11 squared minus 16. And on this side, you get the same thing. So then I check my answer, and we're good to go. So moving on from solving these equations, we looked at quite a few, and you can practice more in the MyLab Math. Now we're going to look at how to identify the type of equation you have. So the equations that we've seen all throughout these videos have been equations where you have gotten a real solution. You've gotten a real number. And when you get a number that works, that you test out and it works, and it isn't part of the restriction, like this one that we just did, we got 11. It wasn't part of the restriction. And it works in the equation. that leads you to an equation that is called a conditional equation. So if your equation is true for at least one real number, it's called a conditional equation. An equation that's true for all real numbers is called an identity. An equation that is not true for any real number is called an inconsistent equation. So you're going to have problems in the MyLab Math where it will ask you, what type of equation is this? And you have to pick one of these three. So we have seen the conditional equation multiple times already. So now we're going to look at, what if it is one of the other two? How do I know? Well, let's look at it with this one. This one says 4x minus 7 is equal to 4 times x minus 1 plus 3. This 4, the first thing I'm going to do is clear the grouping symbol. And so when I clear the grouping symbol here on the right hand side, I will multiply the 4 by the x and multiply the 4 by the 1. Now I'm going to combine the like terms on the right hand side, and negative 4 and 3 are like terms. I'll add those numbers together to get minus 1. Then I'm going to move my variable terms all to one side. So I'm going to subtract 4x from both sides, and I end up with that zeroes out here. It zeroes out also over here, and I end up with negative 7 is equal to negative 1. This is not a true statement. This is a false statement. And so if you ever end up where you're solving an equation and you get a false statement like this, then your answer is going to be no solution. So let's fill in the blanks below. It says this is a false statement. This is an example of what's called an inconsistent equation. So of the three definitions we talked about above, this would be an inconsistent equation. There is no solution here. Let's look at the next one. In the next one, we have to clear those grouping symbols by distributing this 9. So it distributes to both, and I get 9x plus 9 minus 2x. Now I do have like terms on the right hand side. The 9x and the 2x will combine to give me 7x plus 9. When I go to move my variable terms over to one side, I will see that the 7x zeroes out on both sides. I end up with 9 is equal to 9. This is a true statement. And so if you ever end up with a true statement, you're going to say that your solution is all real numbers. So we'll fill in this blank. It says this is a true statement. The solution set for this equation is the set of all real numbers. The set. This equation is an identity. So when you look at the equations, if you end up with one answer, at least one answer, conditional. If you end up with all with a true statement, identity. And if you end up with a false statement, inconsistent equation.